Okay, so in this video I'm going to be looking at problem 2 from homework 3. So this problem involves 3 different derivatives that we're supposed to take, and each one of them is basically going to involve using the power rule, which, as a reminder, says that the derivative of x to the power p is equal to px to the p minus 1. So let's take a look at part A. We're asked to take the derivative of x to the negative 6 plus x to the power 6 plus x to the power 1/6. So we apply the sum rule to say that we can take the derivatives of each of these things individually, and then for each of these terms we use the power rule. So for this first term, we have p equals negative 6. So we get negative 6x to the negative 6 minus 1 gives negative 7. Plus, here p is equal to 6. So we get 6x to the 6 minus 1 gives 5. Then plus, in the last example, p is equal to 1/6. We get x to the power 1/6 minus 1, which gives negative 5 divided by 6. So this is the derivative of that function. Let's take a look at another one. So now we're asked to find the second derivative of 5x to the 4th plus 3x squared plus 1. And so in order to find the second derivative, of course, we first have to find the first derivative. So this is equal to the derivative of the first derivative of this function. The first derivative of this function by the power rule is equal to 20x cubed plus 6x, and then the derivative of a constant gives us 0. So we get this function. Now we just take the derivative again by again applying the power rule. So we get 60x squared plus 6. And that is our final answer. Then lastly, for part C, we're asked to find the 1003rd derivative of x to the power 1002. So this one might seem a bit tricky, not 10,002, 1002. This one might seem a bit tricky because, of course, we don't actually want to take 1003 derivatives. Let's see what happens if we just start taking some derivatives using the power rule. Well, the first derivative of this function, we'd bring down a 1002 and then decrease the exponent by 1. Then if we take another derivative, then we'd bring down the power again and decrease the power of x by 1. And we can see that every time we take an additional derivative, we bring a constant out front and decrease the power of x by 1. So if we do this 1002 times, then we decrease this exponent of the original function all the way down to 0. So after taking a lot more derivatives, we'll eventually get it to having one derivative left over, and we've gotten rid of all the powers of x, brought all the constants down out front. So we'll have 1002 times 1001 times 1000, all the way down to times 2 times 1. So these came from all the coefficients we brought down when we applied the power rule. And this can be written compactly as 1002 factorial. But the point is that this is just some constant, and whatever this constant is, we're taking its derivative. We know the derivative of any constant is equal to 0. So that is our final answer.